Hi, this is Dan from Appland. I'm going to show you how you can optimize your use of Django ORM by seeing how it makes SQL queries under the hood. For this demonstration, I will use the open source AppMap extension for Visual Studio Code to record the code and SQL execution of an application test case and then display that information as a graphical execution trace. The graphical display of code and SQL will help me to understand and optimize my use of ORM. Object Relational Mapping, or ORM tools, enable you to write normal Python code to fetch and manipulate data. Behind the scenes, the ORM makes queries to the database. Using an ORM is very convenient, but it's easy to write code that's inefficient. Normal test cases don't alert you to inefficiency, because the behavior of the code is fine. It's the performance that's the problem. As an example of discovery and optimization of ORM use, I'll look at the SQL for a data model used in the ChaiPy application, which is built using Django. It has a good suite of test cases, including this test for the Future Meetings view that fetches all future meetings and associated venues, topics, and sponsors from the database. It provides a great demonstration of how the Django ORM works. Here's the code and a test that inserts and retrieves future meetings from the database. I've already installed and configured the AppMap recording client, and when I run this test with appmap equals true, an appmap dynamic code trace will be recorded, including the ORM SQL. Here's the appmap. Looking at the trace view, I can see the SQL operations executed by the ORM that allow me to spot any inefficiencies quickly, without having to dive into database logs. I see a select counting active future meetings, then a select that fetches meeting records, followed by 9 selects fetching additional information for each meeting, venue, topics, and sponsors. I'm looking at an inefficiency called the n+1 anti-pattern. If left unchecked, n+1 queries result in the gradual slowdown in the performance of an application due to multiple expensive trips to the database. Let's fix the problem and validate our solution. When I look at the design of the model, I can see 3 cardinality types: many-to-one for the meeting venue, one-to-many for the meeting topics, and many-to-many for the meeting sponsors. The many-to-one relationship is represented as a foreign key from meeting to venue entities, and so the extraneous queries can be eliminated with a join. In Django, this is achieved with the selectRelated query set method. A quick look at the meeting model object reveals that the relationship field is called where. I'll update the future meetings query to use the selectRelated method. The topic and sponsor relationships require a different approach, as they cannot be directly joined. Instead, the query set implements the prefetchRelated method that prefetches records from the related tables, eliminating extra trips to the database for each meeting record. To find the names of the fields for prefetching records, I'll inspect the topic and sponsor models. They are called topics and meeting sponsors. I run the test again and compare the SQL commands in the trace. It worked. As you can see, the sequence of 1 + 9 queries has been replaced with just 3 queries, 1 query with a join and 2 prefetch queries. There are 2 big benefits to looking behind the scenes and inspecting the SQL queries that your ORM is making. First, you'll build a detailed understanding of how the Django ORM works, which is critical to building effective Django apps. And second, by optimizing your application's use of the database, it's now better prepared for a heavy production load. To give us feedback, visit us in Discord or find us on Twitter at Land of Apps, all one word. You can find full usage instructions and all these links on the AppMap page in the Visual Studio Code Marketplace. And you can find more information about Appland along with more videos at appland.com. Thanks for watching.